Let's take a moment to talk about a form of linear equation called point-slope form. Point-slope form. Before we do that, let's just quickly review one of our more common linear equation forms, which is slope-intercept. I know you've seen this before. Y equals mx plus b, where the m is the slope of the line and the b is the y-intercept of the line. So this just makes it nice and convenient. I can just plug numbers in and come up with an equation. So if I know the y-intercept, in this case this line is the y-intercept is 0, 1, and the slope of the line is 1 over 2. So its ratio of vertical to horizontal change as I travel from one point to another is 1 to 2. So as I travel from this point to this point, our vertical change is 1, our horizontal change is 2, and so our ratio of vertical change to horizontal change is 1 to 2. And I can just plug those into this formula. 1/2 x, so slope x plus y-intercept, and we just take the y-coordinate of the y-intercept. Of course, we don't take both coordinates. And this now is a statement which is true about every point on this line. So, for example, the point 4, 3, if I plug in the y-coordinate for y and the x-coordinate for x, and I do the math here, 3 equals 1/2 times 4 is 2, plus 1, 3 equals 3, check, true statement. Or, maybe I want to do the same thing over here with 0, 1, so y would be 0, and, or I'm sorry, that's our x-coordinate. What am I doing here? Y is 1, 1/2, 0 is our x-coordinate, plus our y-intercept, which is 1, and we get 1 equals 1/2 times 0 is 0 plus 1, so check. So true about both points. This equation is a statement that's true when I plug in the coordinates for any point on the line. So what we want to come up with is another way of writing this statement. That's all it is. It's still going to be a statement, an equation that's true for every point I want to plug in. But we're going to write it in a different form. And the reason we're going to write it in this different form is this different form called point-slope is useful when you don't know what the y-intercept is. So maybe the y-intercept, you could see it on the graph, but it's clearly not a whole number, or maybe you're too far away from the y-axis when you graph it, or you don't have a graph, whatever. But if you have the slope of the line, its ratio of vertical to horizontal change, and you have just any point on the line, it doesn't have to be the y-intercept. You can write it in this other form called point-slope. So point-slope form. So the point-slope form can be written in a number of different ways. So here's one example. Y minus k equals m x minus h. Okay, there's one common form. This is when m is the slope and hk is the point. So if I wanted to write the equation of this line over here in this point-slope form, I would just plug in the slope here. And I could use any point. I could use the y-intercept, but I could use this other point as well, 4, 3. And I would just plug in the x-coordinate here for h, because our point is hk. So the x-coordinate would go here, and the y-coordinate would go over here. Sometimes you'll see this written as y minus y sub 0 equals m x minus x sub 0. And still, m is the slope, and but this time the point is x sub 0, y sub 0. So they just change the name of the x and y coordinate in the point that you're plugging in, but it doesn't change the actual formula. There is one other form that you will see sometimes, and it looks like this. Y equals m x minus h, and then it's plus k on the end. So they just move the k to the other side of the equation, and everything still stays the same. Or you might see it as y equals m x minus x sub 0 plus y sub 0. So the only difference here is they've just moved the y coordinate of the input point, the point I'm plugging in, to the other side of the equation. That's all. So let's go ahead and write this equation using that form. So here, my slope is 1/2, and I'll use the point 4,3. So let's go down here. We have y equals, I use that second form. Slope was 1/2. X minus our x coordinate is 4, plus our y coordinate, which is 3. And there, ta-da! And now we could plug in either one of our points to check, and it should still be true. All right, so let's see, I'll plug in the point 0, 1. So that's y coordinate of 1, x coordinate of 0. So let's see, if I plug in 1 for y, 1/2 x minus 0 plus 3. So 1 equals, let's see, x minus, oh, what am I doing here? There. The 0 is supposed to go where the x is. See, 0 minus 4 is -4. -4 times 1/2 is -2 plus 3. 1 equals 1. So check, it works. Or I could do my other point, and that was the point 4,3. X coordinate 4, y coordinate 3. So let's plug those in. So let's go 3 for our y coordinate equals 1/2. Plug in for our x coordinate 4 minus 4 plus 3. 3 equals, well, 4 minus 4 is 0. And 0 times anything, including 1/2, is 0. Then plus 3 is, well, I'll put 0. Then plus 3, well, check. So our equation still works for those 2 points, and it'll work for any other point on the line. So that is slope-intercept form. And again, the reason it's useful is because if you don't know the y-intercept of a line, then you may not be able to easily write the slope-intercept form of the line. But if you know some point on the line and you know the slope, then you can write it in that point-slope form. And that's point-slope form of a line.